Okay, you're on.
Start.
Yep.
Good morning, everybody. Thanks very much for taking the time to spend with us today. I hope everyone can hear and see the slides okay. I'm going to start just by, first I'll introduce myself. I'm Kevin Delahunt. I work for BGE Service and Supply, BGE Air Quality Solutions, sorry. When I was first asked to do this, I was looking at, how to make this presentation relevant for everybody that, or the BOMA group. And when I looked at putting together the presentation, I looked and focused mainly on Class A buildings. Now, the information that I'm going to present is, directed at Class A buildings, but I think all buildings would be able to get something out of this. So, and somewhat of what I'm presenting today is information that, it's my idea or my thoughts, and some of it's the best science and industry advice out there. So, and again, with that, it's a moving target. I think the more we read and hear and listen to about COVID-19, I think the more we realize that, what was true today or yesterday is not necessarily the same today or tomorrow. So you have to take it with a grain of salt, perhaps, and, move on from there. Now, we're going to have lots of time for questions and answers. So if you do have a question, there's a dialog box or a question and answer area. Take time, fill out your question, and we'll address them at the end. Like I said, I think we'll have all kinds of time at the end to do that. So BGE Indoor Air Quality Solutions, family owned and operated since 1968. We've been around a long time. Our head office and manufacturing facility is in Edmonton, Alberta, with 7 branches across Western Canada. And I believe now we probably have about 175 employees across Western Canada. Our mantra is to deliver clean, healthy indoor air environments. That's what we go to work and deliver on a daily basis. Myself, I'm a senior technical advisor, which is a nice way of saying I'm semi-retired or mostly retired and spend my time doing research and a little bit of writing and actually quite a few educational seminars. I've given talks like this right across Western Canada and even into the United States, delivering education to customers, to contacts, to industry associations, just pretty much anybody will listen to me talk. So today we're going to focus on 4 aspects of building operations: stakeholder management, mechanical systems, system integrity, and professional development. And I'll tie these all together with my talk and how they relate to indoor air quality. A lot of the information, and I'm going to apologize right now if I'm repeating stuff that you've already heard. It's pretty hard not to, but a lot of it needs to be reiterated. There's some things here that we need to drive home again and again. And secondly, there'll be some information that you probably haven't heard yet that I think will be important to how you operate and function buildings going forward. Now, as I mentioned, I've done presentations like this, probably 30, 40 times in the past 10 years. And this is a slide I had when I was putting these all together. I looked at some of the slides I had and I looked at, what will the building of the future or the near future look like? And there was 2 things that really jumped out at me. One was super viruses, because I put that in there, which you could easily say the COVID virus now is a super virus. It's obviously it caused tremendous impact to, the health and safety of everybody, as well as an impact on the economy. And the last one is increased awareness of indoor air quality issues. So with this one, it's specific for, I think there's nobody in this world right now that hasn't been impacted by COVID, hasn't got on TV or read something about it. And the knowledge that they're gaining about especially indoor air quality has been probably exponential since last February or March. And I'm going to talk more about it on that as we move forward. So when people enter your building today, what do they see? What do they see that's different? Well, I know when I go into a building or anywhere now, I see, tremendous amount of cleaning, people walking around there, you sit down in a chair and you get up and there's someone right behind you wiping the chair down. You go to the grocery store and they wipe down the baskets and the carts. I see a lot of mask wearing, which is really good, and all kinds of signage on the floor and plexiglass and separations and that type of thing. But what don't they see? They don't see the quality of the air in your building. It's invisible, well below your sight lines. Before we get too in depth into the 4 aspects that I talked about, we're going to break down a little bit on some of the key concepts that we're going to discuss. And so, like I said, a lot of these you've probably heard in other presentations. A lot of it needs reiteration, though. So my foray into this area, I was sitting in a small little town in southern Arizona in February, about 5 miles from the Mexican border, and I was feeling quite safe and, isolated compared to a lot of other people in the world, and the world was starting to go really crazy at this time. So, and this came across, one of the networks that I was watching. It said coronavirus is transmitted via large droplets that quickly fall to the air. The virus is not airborne. And this came from the BC Centre for Disease Control. Once I read that, I thought, man, that defies everything I know about a particle and how they either settle or stay airborne. It did not, it made me react and question this statement. And I think it was important at the time to question it, because immediately after that, ASHRAE came out with the coronavirus can be spread through airborne particles that can linger in the air for minutes or even hours. So what we're finding now, and the more that they do research and science behind it, is that yes, the particles are airborne. Yes, they can stay in the air for extended periods of time. And in some cases, they're viable for longer periods of time. The Center for Disease Control quickly followed and said transmission of SARS-CoV-2 through the air is sufficiently likely. And limping along, come November, Canada finally raised the awareness that yes, COVID-19 spreads to include the risk of aerosol transmission, being that it can float through the air or stay airborne for an extended period of time. So I don't know about you, when I first started doing some reading and research and sitting in presentation, I probably sat in 30 or 40 webinars related to COVID and air quality. There was a lot of different terms used for the virus size particles, a bioaerosol, microorganism, airborne transmission, and I was rather confused. And even reading about this, I get even more confused. So it was very hard to decide, exactly what are they talking about. So what I wanted to do was try to break it down. We already know that an aerosol is a liquid or solid particle suspended in the air. So we know that humans breathing, talking, singing, coughing, sneezing will create tremendous amount of particulate, and some of it will drop and some will stay airborne. But again, talking, coughing, sneezing, whatever. And there's even a point that perhaps it can come up through a toilet through feces. So we think about modes of transmission. So it's all about the size of that particle. So when, and you have 3 different modes of transmission: the contact, the droplet, and the airborne. So the contact is that immediate, close contact with the individual that is affected with COVID virus. And the size of the particles are greater than 10 micron, and I'll talk a little bit more about sizing and that. And it usually happens in very, very close contact. The second one is droplet transmission, and it's usually a larger size particle, and again 3 to 5 feet. So hence that 6-foot separation, or the social distancing area. The third, though, is what I'm really interested in, and again, goes against what the BC Centre for Disease Control had said, is about airborne transmission of the virus. Again, extremely small, below 5 micrometers in size, and would have a tendency to stay airborne for extended periods of time. So again, in reviewing what I read about, from the BC Centre for Disease Control, my first thought is that COVID is a particle. It actually has mass and size and weight, so it should behave like all other particles do in that size range. And if you look at a air contaminant size, and I don't know if this helps a little bit, but you would, the viruses run extremely small, like you're talking about 0.001 microns in size up to, about 0.1 microns in size. And this is, again, very impossible to see, well below your sight threshold. So I know I find it really hard to visualize this. So when I was trying to think about, how do you make that invisible size particles sort of visible or make it relevant to you? So I said, if you're sitting at your table right now and you get your coffee in front of you and maybe a bowl of sugar or whatever, you take out one granule of that sugar and you cut it into 5 equal pieces. This will be the size of the small droplets, the ones that will happen through close contact. And then if you take that 1/5 of the granule of sugar and cut it into 15, that'll be the size of the next particle, the larger one. And then if you cut that into, again, another 15, you get an idea of just how small a naked COVID-2 virus is. Take a granule of sugar and cut it into about 600 pieces. That 1/600 piece is approximately the size of a COVID or SARS-CoV-2 virus. Extremely, extremely small. So the thought of this very, very small particle actually settling out of the air defied everything that I knew about particle dynamics. It's just too small to do that. And as I was mentioned, particles don't settle out of the air like you think they would. Like if you had a particle and you put it to your shoulder and say, let's just say a 10 micron size particle, and you dropped it at shoulder height, it would take 5 minutes to fall to the ground. If you have a 1 micron particle and you dropped it from the same height, and you can actually put a 1 micron particle in your hand, it would take 8.5 hours to fall to the ground. And that's in the perfect conditions with no ventilation, no people, no movement, what have you. So what we know about the size of that, a virus-sized particle, is that concentration is obviously a really big situation. And if you look at the air in the space that you're sitting in right now, 99% of the particles in that air are in that virus size range, well below your sight threshold, and would not have a tendency to settle at any, in a short distance of time. It would take a long time for them to actually settle. So the conditions that you need to be considering when you look at your building is that where are the highest risks associated with? Well, you got to look at crowded spaces, and now you start seeing, like if you go to a restaurant, you're separated, even if the restaurants are open, but we've really reduced the amount of people in the space. If I go get my bread now, there's only 2 people in the store at a time. So we've tried to eliminate or break down the amount of people in an occupied space. The other is prolonged time and exposure. The longer you're in a space, the more chance you have to breathe that same air that could be contaminated. And the other two are inadequate ventilation and inadequate filtration. And with all these together, if they're not working in conjunction, if you're not purging the air and filtering it, you'll build up high aerosol concentration in that size range. And again, it could be the size range with COVID or SARS-CoV virus in it. So there's lots of things we don't know. And by the time I finish this, some of these might be answered, and you might even have an answer for it. But I don't know the production rate of the infectious aerosols by an individual. Now, when they sneeze or cough or laugh or sing and they give off a plume of particulate, how much of it is infectious? Is it 100%? Is it 10%? Is it 1%? I don't really know. And the relationship between exposure and risk of infection. If I was in that room when someone again, gives off this plume of aerosols. How much do I need to before I get infected? Is it 1%? Is it 10%? Is it 50%? I think and it might be different for a lot of people depending on their health risks or how vulnerable they are. How long the virus stays viable in the air, or for that matter, viable in your air filters. So I have to be concerned, like, is the virus viable 5 feet away, 10 feet away? And a lot of things I've been reading is that in the air it can still be viable an hour and a half to 3 hours after it leaves a person, which is a heck of a long time, which gives it all kinds of time to get back to the mechanical systems, which in turn, does that make your air filter now a hazardous product to service, to remove, to dispose of? A question that hopefully we'll address by the end here. And again, until science knows the answers, we have to err on the side of caution. So we went from being the virus is not airborne to there's a very good chance that it's airborne to it is airborne, but in what concentration and how viable. So I think we probably have to be concerned about, well, if it is airborne, you know, how do we remove it? How do we make sure everybody's safe? So as I mentioned earlier, ventilation and filtration are the keys to reducing aerosol concentration. We need to get more air in the building and we need to filter it better. So mechanical systems, ventilation. These aren't from me. I've taken these mostly from ASHRAE, but anywhere that I think the device is sound. And you probably heard most of these, especially in your facilities, but maximize outdoor air supply. Try to bring in as much outdoor air as you can. Run systems longer. So we have a warm-up cycle in the morning, run it approximately 3 air changes, which in most commercial buildings would be about half hour before. Make sure you run it. Run a pre-humidification prior to that. Get some humidity into the building and do an end-of-day purge. And lastly, verify your HVAC system with design intent. Are you getting the ventilation per design? And obviously I don't know if this is done on a regular basis, but if it hasn't been done in a while, this is a great time to do it. Contact your in-house engineer, or if you outsource that sort of thing, and take a look at, are you getting the amount of flow that the building was designed for? And over time, there's lots of changes that have to happen to HVAC systems that you need to take a look at and rectify those. Get more air into the building. And how do you decide on that? Well, you reach out and you look at ASHRAE standard 62.1, ventilation for acceptable indoor air quality. So in it specifies minimum ventilation rates for areas in your building, how much CFM to bring in per person for the locations, and you would relate that back to the air handling unit. It doesn't matter what you read, or if you're sitting in webinars, they're going to talk about ventilation. They're going to talk about bringing more air to the building and providing a healthier environment, just diluting through ventilation. No different than probably your house. If you get a chance, you open the windows and the doors and you just purge the air that could be considered stale in that space and replace it with outdoor air. Filtration. If you upgrade your filtration system, you will provide immediate improvement in air quality. As soon as you make the adjustment, you see a difference in the amount of particulate that exits your filtration system. Immediate. And you do this in 2 ways. One is just simply upgrade your filter. If you got a MERV 8, you go to a MERV 10. You got a MERV 10, you go to MERV 13. And you'll get immediate results. And the second one is approve it through system integrity. Make sure all the air goes through the system, the filter system. And this sounds really logical, but I guarantee you right now that a lot of systems aren't working the way that they were, the way you purchased, the money you spent, or the way it was designed. And I just like this comment because, you know, after ASHRAE recommended MERV 13, MERV 13 media was impossible to get. So unless you had a really good supplier of media, you ended up probably having to wait for a MERV 13 filter if you were upgrading or even if you were using MERV 13 filters. So back to ASHRAE Standard 62.1 2019. The standard today, if you read it, basically says that the standard for acceptable indoor air quality is a filter of a MERV 8 or less. So a MERV 8 filter, if you're not familiar with that, would be, you know, a 2-inch pleated filter, even a 1-inch pleated filter. If you go to Canadian Tire or Home Depot and you look at that wall of filters in there, most of those are probably MERV 8 or less. So it's not a big stretch. It's not a you know, and as part of the industry, we've been promoting a much higher filter for a longer period of time. And I think, if anything, ASHRAE was caught short here, hence their reason for upgrading to MERV 13 or recommending to MERV 13, because a MERV 8 filter is just, and I'll show you later, is not capable of servicing virus-sized particles. ASHRAE, about the same time that they came out saying that the virus, there was a good chance the virus was airborne, then started recommending MERV 13 and preferably MERV 14. And I wonder, as an industry, and I've polled a few of the salesmen with BGE to find out, but how many people, because at this time most people were working at home, March or April, you know, had to question, boy, are our systems MERV 13? Probably quite a few, because I know we had quite a few calls just to verify that. Now, the good news about this is that most of the Class A buildings in Western Canada, they were designed with MERV 13 filters. They're already there. Most of the buildings in the United States, and a lot of the buildings in the United States, a lot of those beautiful buildings that you see on TV, they were designed with MERV 8. So they had to immediately upgrade to a MERV 13, which at that point, it's a quantum leap in filtration. That is a big improvement, but a big upgrade also. Here, we're already there. Most of our buildings, if you look at the buildings downtown Edmonton, downtown Calgary, all the big ones already had MERV 13 filters in it. So today, again, ASHRAE Standard 62.1 2019, next update, probably MERV 13 or MERV 14. And for ASHRAE, that is a quantum jump in performance, because it took them a long time even to get to MERV 8. Up till, I think, 2016, it was still only MERV 6, which is, you know, not much better than a furnace filter. So in case you didn't know who MERV is, it's minimum efficiency reporting value. And again, it comes from another ASHRAE standard 52.2 2017, which is the testing protocol for filters. And then it addresses two important air cleaning parameters. One, the ability of a filter to remove a particles of specific size. Now that's really important, because if we know the size of the airborne virus, and we know virus-sized particles, would you not want to have a filter that's really efficient on that size particle? And I'll tell you right now, the MERV 8 is not one of them. And the second one is resistance to airflow. As we put a filter in, and again, the more efficient filter that we put in, it's going to cause more restriction and reduce your ventilation. So ventilation, filtration got to work together. We don't want to put in a filter that's going to restrict the ventilation into the space, but we do want a filter that's, again, going to stop the particle as best you can. So I usually like to say you got to do the best you can with the equipment that you have. And again, in most cases, Class A spaces, Edmonton, Calgary, very high efficiency filters already. So if we were looking at this chart right here, what you would see is, and I'm just going to get my pointer here. As I talked about the MERV 8 filter, so particles in the virus size range are in here, 0.1 to, I'll even say 1 micron, and I'll use 1 micron as just an example here. So a MERV 8 filter is going to be about 20, let's say even 25% on a 1 micron size particle. At a half a micron, it's only about maybe 15%. That means everything else is leaving that space. So at 15, you got 85% of the particle goes right through the filter, back into the ventilation as return, and it becomes return air. unless you're exhausting, which most buildings can't do 100%. So we go to MERV 13 and I look at the 1 micron size particle. It's at about, well, let's say 80%, a dramatic improvement. So you can see when I was talking about, especially in the United States, going from MERV 8 to MERV 13 is a dramatic, drastic, a quantum leap in performance. And even at the 0.5 micron size particle, it's still at about 50%. So big improvements there. And if one thing I was talking about, like you can upgrade your system and you would see a noticeable difference right away, even going from 13 to 14, even though this doesn't look like much of a range. I'll show you here in this bar graph, you get an idea of just how much is penetrating the filter, because at the end of the day, what we really want to know is what's exiting the filter. It's nice to know, yes, it's that efficient, but a MERV 8 filter is, virtually 95% of the virus-sized particles will go right through that filter. And a MERV 13, you're looking at about, maybe that's 35%. And jump into 14, sorry, you're at about 20%. But the difference here, again, is really important because you're reducing that particle load about 75% just by going from 13 to 14. It's really quite a great improvement, really, when you think about it. And you're diluting that particle because, again, most commercial buildings, you're returning that air. So which air would you rather return? Which filter would you rather have? MERV 15, MERV 16, very little penetrating in MERV 16. And if you go into the HEPA filters, which are referred to the right here, they're virtually absolute 100%. The only thing, you can't get any air through it in a commercial design. I hope that makes sense. It's a shame I don't see anybody because I can't see if I get some heads nodding or shaking, whether you understand it or not. So one of the other aspects that needs to be addressed, and this is not coming from me, but I mean, I've read an awful lot of stuff on it, is that relative humidity, maintain relative humidity between 40 and 60%. Now, I know that the facility guys, and I can just see you shaking your head right now, because in January, February, when the air is about, I don't know, 12, 13, 14% RH, how do you mechanically humidify to get it to that, to those numbers? Extremely, extremely difficult. Almost, and I think it's probably impossible, but it still bears repeating, bears commenting about it, because there's really good reasons to be doing this. And one of them is that in moist environments, the particle that comes out that is expelled from an individual will stay still moist and buoyant and not buoyant, I guess, and would drop to the ground, which is, a good situation here. If it's dry, it will have a tendency to, again, shrink, smaller in size, and the smaller in size we know would stay airborne. So absorption and ventilation are two important aspects in how the particle could be transmitted through the air. And the second one is just your body's defense mechanisms. We have better defense mechanisms and able to reduce or to eliminate or to impede the virus from entering the body if our nose and mouth and larynx and that are moist. And in dry environments, as we have, in Western Canada especially, it's very hard for our bodies to, to act as a defense mechanism as well in a dry environment. So some of the other technologies that I want to talk about are room air cleaners, UVGI, and on-site medical rooms. So the first one is room air cleaners. There's lots of comments and debate out there about room air cleaners. And again, they need to be employed and strategically placed, because there is some actually science in how you put these in a room. They do work. They do offer some supplemental quality of air and ventilation. And you're looking at where would you put them in some crowded spaces. So, and again, maybe a waiting room, that type of thing, if there still is such a waiting room. Prolonged time and exposure. when people would be in a place for extended periods of time. You might want to just, again, scrub the air into those areas. And inadequate ventilation. So when you do your verification of your airflow and you're not getting air into specific locations, these would be good areas maybe to throw in a room air purifier, room air cleaner, and they're ideal for those applications. Ultraviolet germicidal radiation is a proven technology, has been around for 60, 70 years and been used a lot in the medical industry. Has its place even today. There's many different styles of the product. You can put it in duct to try to kill maybe what's on a coil, or even a flyby reduction of live virus. There's also in-room ones like this picture shows right now, just decontaminating a room after someone has probably left it, maybe a patient. There's upper room irradiation that works really well too, and they use that a lot in hospitals just to again to impede their inert virusized particles. On-site medical room is just one that I've read a couple things about, and I thought this is not a bad idea. So my vision of this is that if you had, someone in your building, and when people start getting back to the building and you have 1,000, 2,000 people in the building, it's probably a very good chance that someone gets sick. How do you evaluate that situation? And as the testing protocols start to change, and we're starting to see some, almost real-time testing procedures, do you really want the person walking through the whole building or office, or getting on a bus to go home or to the hospital or whatever? Maybe you have an isolated area where they could go to, do even a self-administered test, evaluate themselves, and decide, what the next step is. And the interesting thing about a room like this, it would be, I always envision it sort of like the nurse's office back in grade school or high school, where you'd go get your flu shot, or maybe get tested for I'm not going to say what, but just again, to discuss medical issues. But look for an area that has negative air in it, and when I look at a building, and negative air in most of the buildings is like the food court, where you have a food kiosk where the air is exhausted from the cooking area as directly outside. So the air wouldn't go back into general ventilation, would be exhausted or cleaned at that point. So there is, I think there's a bit of a case for this. It's sort of novel. I don't see any buildings jumping on it right away, but I think down the road it might be a nice feature to have in a building that allows you to do something a little bit different than maybe somebody else. System integrity. So very first thing is, as I talked about, how do you improve filtration? There's two modes. The simple one is just change the filter, and you can do that. But if you don't do this one, you're just wasting your money. You really need to reach out to someone like us, or another filter supplier, somebody that is knowledgeable in air filtration systems, and have a look at your system to identify, again, the bottom line is all the air going through the filter. And if you don't do that, at least let us educate your staff to make sure that they are aware of what to look for. And some of the things that we look for when we go into a system is that, very first thing when you're looking at a filter bank, especially a large one, is the filter bank rigid? And there's many banks that I go in that, that were designed originally totally rigid, that I can push probably a foot backwards and will bounce back a foot forward. That bank is not rigid, and there's a very good chance any of the seals that were put on between the frames are now broken. Are the filter channels clean? You need quality gaskets either on the filter or on the hardware. Get all the clips. Are the clips lying on the ground, or are they actually on holding the filter in place? And that's really important too, because the filters will have a tendency to fall out if they don't have a clip just holding them in place. And really the bottom one is looking for leaks between the plenum, the framework, the channels, anything like that. and we'll talk briefly about that. The bottom line, it doesn't fit, it doesn't filter. And all air wants to pass through a filter. Air does not want to pass through a filter and will take whatever means to bypass it. Just like water, it's going to look for the path of least resistance, and it will find it. And it's actually quite easy to spot it just by the dirt path that's left behind. And as we increase the filter, it's even more important because as the filter's efficiency increases, the pressure drop on that filter increases, and the more the air will want to bypass it. Even more important is the fit in the system. Filter hardware and filter efficiency are of equal importance. They don't get mentioned very much, but if it doesn't fit into the framework, it just doesn't make sense to upgrade to another filter. If your MERV 13 filter doesn't fit, buying a MERV 14 isn't going to change your filtration performance. It needs to fit. Here's a good example of one that doesn't fit. This filter on the right here is, it's probably about $150 to $175 filter, MERV 15, hospital grade. And for this little area here where the sheet metal maybe just didn't come down enough to hold it in place, the air is now bypassing that filter. Now, the interesting thing about this is that what we've done is we've taken now a MERV, 15 filter and turned it into perhaps a MERV 8 or MERV 9 filter. So this MERV 15 filter at $150 is behaving like a filter that you can probably buy for $12 to $15, just because of a little piece of sheet metal or the lack of an extension on that U channel there. And again, a really, really easy fix and not expensive. Bypass between filters. I've been in the industry a long time, and anytime that you put filters, slide them into a U channel and length, side axis, rooftop unit, you put more than one filter in there, it's impossible to get a seal. Metal on metal, cardboard on cardboard, just don't seal. This hasn't changed, again, in the 40 years I've been in the industry, and it drives me nuts that we can't come up with a better method to actually tighten these filters in place so that all the air goes through the filter. And it is, we need better filter hardware. Filter efficiency is changing, the products are changing, everything's evolving except for the hardware. As far as I know, again, the last ones I've seen, it's the same as it was 40 years ago, probably even longer than that. You slide them in and you hope that you get the same performance. So the message out there is now put MERV 13 in where you had maybe a MERV 8 filter in a rooftop unit. Is that going to give you MERV 13 performance? No, it won't, because we don't get the seal, we don't get the tightness that we need. The fixes are quite inexpensive, and many systems have, you slide in a 1-inch track bag filters or cartridge type filters. These filters can stay in place 15, 18, 24 months, a long time. A little tube of caulking, perhaps just to seal them together, create that bond as you slide it in there, will help seal that in place and hopefully guarantee that all the air goes through the filter. And if you can do that, then you can comfortably say, I got MERV 13 efficiency in that system. But if you don't do that, you hope you're getting MERV 13, but you're probably not. Even us filter geeks, we tend to do some science, and the National Air Filtration Association sponsored this one. Well, they actually looked at filters of different efficiencies and rated how they performed with some bypass. So a MERV 7, MERV 8 filter, you can have quite a bit of bypass. It doesn't really change the whole nature of the product. It, might drop one MERV rating number. Not a real big issue, but again, getting back to those filters, we looked at the bar chart. 90% of the virus-sized particulate penetrates that filter anyway. So at the end of the day, whether it's MERV 7, MERV 8, or MERV 6, it doesn't really affect the performance a lot. But a MERV 14 filter, where you've made a substantial investment in that product, can lose up to 6 points in MERV. And as I mentioned earlier, in that MERV 15 filter, you get a MERV 14 filter, now acting like a MERV 6. You're putting good money after bad. Cut to the chase and just put a MERV 8 in there, because that's the performance you're actually getting in that space. So, and I'll make a point right now, the best money that you can spend is just going through the system and make sure it's designed. If it's a MERV 8 system, let's make sure it works to MERV 8 performance. If it's a MERV 13, let's make sure it works to MERV 13 performance before we start upgrading. And these are all basic things, things that you need to do on a regular basis that they just don't get done. And over time, things happen. The systems do break down that need to be repaired, and the repairs are very inexpensive. In this case, you see just the gasketing coming off a filter. And a lot of people will look at that and say, oh, it's, I'll just put it back into place, without really seeing that, maybe the air is bypassing. And you can easily see that because the outside of this filter, which should be sort of the clean side of the filter, will have a dirt not coming through the filter, but actually going beside it. So between the door and the filter, it leaves it just leaves a pattern of dirt, because the air is now whipping beside, on the side of that filter. And you'd also see it on the coil. So you look at the coil and you say, downstream of a MERV 13 filter, which these are, the coil should stay relatively clean. If all the air is going through that filter, the coil is not going to stop particles. Like, the coil is very porous, so it shouldn't get dirty, but it does. And if it gets dirty, you have to question, where is that dirt coming from? Probably not coming through the filter. It's coming either around the hardware or right beside the filter. So door gasketing, the same thing. Like, you see a lot of dirt around this door gasket. That's where the air is just bypassing the system. It's going to the path of least resistance. And in this case, it's, let me get around the door, and I'm leaving almost a dirt path that shows, where the air is going. Again, easy to replace. What does new door gasket cost? Probably, 15 or 20 bucks to reseal that. That's probably good for another 20 years. Filter banks over time can collapse. I've seen many completely collapse just by, lack of maintenance, and fixing this is rather easy and inexpensive. We've done hundreds over the years where we've just gone in and put, so maybe some angle iron behind the system just to support it on that vertical structure right there. And I tell you right now, the seal between these filters, and these are really a high efficient filter, probably again MERV 13, 14, or 15, they're probably not acting even close to that. And you would see the same thing downstream on the coil or whatever with dirt. Gasketing come to the door. Here's what you see is that, and this happens a heck of a lot in my, drives me crazy. I'm going to tell you, like, either there was a spacer in this at one time that was supposed to take up this 2-inch space, but that is right open to the coil right there. So the air is coming this way, and you're going to have a tendency to go right around it. This is a restriction to the airflow. The air is going to now look for a path to get around it, and it'll take that path right around the filter. So you need to look at that and say that is a big gap in this whole system. This could be a MERV 13 filter, again acting like a MERV 8 filter. Why spend the money? And I'll mention it again. The best and easiest money you can spend is just making sure your systems operate the way that they were designed or intended to. If you see dirt on the floor, where is that coming from? Especially if it's downstream of a filter. And I've seen some you had to go in with a shovel to actually get out, even aphids down there, small bugs, that type of thing. This is a HEPA filter right here, which can be $300, $400, $500 a module. And I would dare say that's probably 6 or 8 inch space right there where the air is completely going unfiltered into a HEPA filter. The last thing you want a HEPA filter stopping is particles this size and loading it up prematurely, just because of the cost and in the pressure across it too. So, and again, it's just a matter of looking at this and asking that question, where And how is this dirt getting downstream of these filters? It's not probably going through the filters. I mean, it could be, but it's probably not. And if it was, you would probably have damage like this. You would go in and look at the system and say, oh, okay, this filter is damaged, needs to be replaced. And there's very good reasons to be looking at filters on a regular basis. They can break down just like anything else. And once you have even a very small hole in the filter, it will affect all the filters in that bank. I've seen cases where it started with one small hole and took out one filter, and then the filter next to it, and then next to it. The air in there concentrates on these, again, paths of least resistance, and will completely destroy a filter. Filters are designed for a certain velocity. Increase that velocity 2 or 3 times, and this is what happens to the filter. So again, they need to be looked at, monitored, and replaced if you see any damage to the filter. This is just an example that we saw in the most recent one. We looked at, okay, these bags are put in sideways. So, and this happens a heck of a lot, 50% chance of doing it wrong 100% of the time. Just needs to be turned 90 degrees, and that you'll have vertical flow. The filters work a lot better if the pockets are in a vertical position. Very, very simple. The gasket's fallen off. Well, again, that can be fixed, even a little bit of glue. These are going to get thrown away. Do you really care? The spacer that created this or filled this space is lying in the filter tracking, not being used. The tracking's really dirty, which gives me an indication that something's going on there, and especially around the door, there's lots of dirt there. The filters don't come to the door, so they don't fill that whole space, hence why the piece of hardware sitting lying in the tracking. But it has a great door gasket, so you got that going for you. Bottom line, again, you're not going to get the filter performance that you wanted. The fixes are really, really, really simple, but you have to be aware, cognizant of it, and prepared to, you know, spend the time just fixing it and make it work correctly. Make it work as designed. Duct tape works wonderful. As I was mentioned before about the side axis units, like they're horrible. And as we increase in efficiency, they're only going to get worse. Putting a MERV 13 filter in a side axis unit, you're just not going to get the performance unless there is sealed between the two filters. It just doesn't work that way. And spacers, again, very inexpensive. Put them at the far end of the unit if you can, but put something in there just to make sure that you fill right out to the door. Put some gasket on it, make sure it fits. These again are very, very inexpensive remedies to the situation, and will help, you know, filter all the air that's going through it. My mantra is the goal of every filtration system needs to be system performance, not just filter performance. And the only way we get this is if the hardware that the filter sits in becomes just as important as the filter. This doesn't get mentioned very much, and it doesn't get the attentions that's due. You can't get the performance without the filter hardware working just as well as the filter itself. And that goes for every system, even your home furnace. If you want to put a MERV 13 in your furnace, you got to make sure that the air goes through the filter, or you just wasted your money. So the next aspect we're going to look at is professional development. Safety. Safety is a really big issue, every industry, but especially now in the filtration industry. Do you have the right procedures and practices put in place for replacing filters? And are your guys trained to understand, you know, the proper PPE? You think you put it in a filter, and I was saying earlier, it could last 15, 24 months of all the crap that you didn't want to be breathing is now in that filter. Do you really want to be handling it with bare hands, no glasses, no masks? No, you want to make sure your guys have all the PPE, they wear it and they wear it correctly, they dispose of it correctly. And once the filter is removed, that it's handled with care. because it's very good chance that it is hazardous. So train your staff on servicing filters. The National Air Filtration Association has an excellent certification program. Go to www.nafahq.org, have a look at it. We've put a lot of people through this over the years, customers and our own staff, but we can help in the assistance with the training and education and getting the designation. And I think for the guys, it's really good because it raises the importance and awareness of servicing a filter. And right now, it's becoming a specialty. We have specialists in the industry that, just do, HEPA filters and certification in hospital ORs and areas that require extremely high level of cleanliness, which is no different now than in an office building. So some of the things they look at is the best practices for installation removal, working in a safe manner, the PPE again, and safe handling and disposal of filters. And I'll say it again and again, and I use this an awful lot. If you take out a filter that's been in the system for 18 months, open it up and put a Petri dish in the inside of that filter and let it sit for a few days, you'll have something growing, and it won't be something you would want to be breathing. So handle the product, the spent products, with some degree of care, and with the idea that it could be a hazardous waste. And it could even have virus in it, and whether it's live or not, you still don't want to be handling a product carelessly. So duly noted. Stakeholder management. When I started putting this together, I'm saying, like, okay, we go into a building, we see all these things going on, but we don't see the quality of the air. How do we make the invisible visible? We know that the particles are there, but we just don't see it. But we need to do this, and we need to communicate it regularly. And I just don't see it done. And it's been something that, again, has been driving me crazy for a lot of years, because the bottom line is the quality air in most buildings, especially commercial buildings, is really high. It's really good. What we fail to do, though, is to communicate that with our occupants. And I'm not sure why, whether it's legality issues, or we're just worried about, identifying a sick building syndrome problem, but it's just something that it just doesn't get done. And I think it needs to get done going forward. And some of the reasons it needs to get done, because the way I'm thinking is that if you don't do it, someone else is going to do it, and it's someone you don't want doing it. And that could be a tenant. They could be having, you could get an app on air quality, indoor air quality, and they could be coming and giving you whatever information on their little app that is really not relevant. It's not accurate, and then you have to defend it. It would be much better for us to be proactive and communicate that to tenants. And I'm going to show you some ideas of communicating that. But first, I'll show you my Florida speed bump. I like to bike, and I like to say, well, I like to bike almost every day in the summertime, but there's a lot of days that I have to, I'm a fair weather biker. I look outside, if it's raining, I don't go. If it's too windy, I probably don't go, or I watch the way the wind goes. But over the last few summers in Western Canada, I also looked at the Air Quality Health Index, and you're probably aware of this, that, because we've had a lot of days, mostly from wildfire smoke. But the government of Canada has been doing this for decades, taking readings downtown Edmonton and Calgary, and they'll do ozone, fine particulate matter, PM 2.5, and nitrogen dioxide. So your outdoor air is already being evaluated by someone, and they get reams of data. They do this constantly. I have an app on my phone. I look at it. If it starts getting, 7, 8, or 9, which we've had lots of days, even 10 plus, I probably don't go bike riding. It's just not a good idea. And this picture, if you might have seen this before, but this is downtown Edmonton. What's the date? Yeah. August 15, 2018. So that was the air that if I got on my bike, and this is at 10 o'clock in the morning. So that's the air I would be breathing. That's the air that you're bringing into your building to provide ventilation to your space. So very low quality. Again, where would you want to be? If you're in a commercial building and you're scrubbing this at, 85, 90%, the air quality in your building, particulate wise, is much better, way better than outdoors. Why don't we promote that? Why don't we say that? Here's the air outdoors. It's coming in at high risk of, let's say, air quality index of 9, and indoors, it could be a heck of a lot better, like probably 2 or 3. We already do most of this. Most of the buildings I had worked with in the past are doing TVOCs and temperature humidity. You do this real time. You monitor it. You have tons of information: carbon dioxide, carbon monoxide, particulate, that type of thing. Again, the only thing we don't do is that we don't promote it. We don't put it out. And I'll say right now, I think, especially in a Class A building, this is a competitive advantage. And it's a competitive advantage. Where else is the air any better? Maybe in a hospital, maybe in a laboratory, but it's a heck of a lot better than a lot of days outdoors, a heck of a lot better than in a school, a heck of a lot better in a old age home, retirement center. Where would you rather be? What air would you rather be breathing? Let's promote it. Even in our, I don't know, Class C or D building in Calgary, we have this. When you come into our building now, up on the screen, we'll show you the air quality outside, the air quality inside, and give you an idea of the quality of that air and give you some sort of rating. And it could be color coded or a number or whatever. And in this, we also have carbon dioxide. So carbon dioxide, as you're probably aware, is a great surrogate, or how do I do that? If you look at where carbon dioxide rates on, into ventilation. So it's a surrogate for ventilation. Are you getting enough ventilation in the space? So if I take that 635 and I look at this graph on the left-hand side, somewhere in here, I know that I'm getting well above the ASHRAE recommendation of around 15 CFM per person. I'm getting around, 25 to 30 CFM per person, which is really good. And I'll tell you, this ain't a Class A building, so I hate to say it, but it's just not. So we need to market your accomplishments. Some ideas to communicate on, if you're going to put this up in your building, is the ventilation rate. So we look at how much air change are we getting in the space, how much air change per person. Maybe days in the green zone. If you have a color-coded air quality index that says, oh, we've had 10 days in the green zone, high air quality days. You got comparisons, you get the data. I think doing that comparison is relatively easy. And I'll say again and again, the air quality in your buildings in the Class A space is much better than a lot of locations outdoors and a lot of smaller buildings. So, you can also highlight maybe your system upgrades. Hey, we went from a MERV 13 to a MERV 14 filter, or we validated our systems and we now know that they're running at MERV 13 efficiency. And some of the industry recognition that you would get, some, LEED credentials, BOMA Best, Well, Fitwell, a NAFA Clean Air Award also, are things that you could show on this, accomplishment board. I think we need to make this visible to people as they come into the building. And I don't think anyone has to be worried about putting this up because, again, the air quality in your building is very good. So some final thoughts here. I think we can all agree that air quality has been one of the most important organizational health and safety issues since the pandemic began. We've been bombarded by information on air quality, ventilation, filtration, virus-sized particles, you name it. So it is very topical, but it's topical not only to us in the industry, but now to your tenants. This heightened awareness will not diminish, but will become the new benchmark. What we're seeing right now is that, again, it took ASHRAE 20 years to go from, a MERV 6 to a MERV 8, and it's only going to take a few months to go from 8 to 13. This will now be the benchmark. Going forward, they're not going to go back to MERV 8 saying that's acceptable for indoor air quality. MERV 13 at least will be now the benchmark, and if not MERV 14 or MERV 15. Some strategy can be really expensive, and you guys have probably looked at some, you know, that are being floated out there, the be all end all for COVID reduction or SARS-CoV-2 reduction. But the real thing is get back to the basics, and in not doing the basics and then going ahead and trying something novel, like, really doesn't make sense. It's not good money. The best money to be spent, again, is to make sure the systems that you already have in place, they're already designed there, are operating the way that they were designed. The correct ventilation, the correct filtration, and all the air is going through the filters. So steps taken today to improve your IQ will enhance your building, providing a better work environment. And I'll mention it again, I think Class A buildings, even Class B buildings, have a competitive advantage over all kinds of other buildings. And prospective tenants and tenants coming back into the workplace are going to want to know the quality of the air. They can see everything else that's going on, the mask wearing, the cleaning, the plexiglass, the signage, and that sort of thing. But the thing they can't see is the air. When we can show them that air, we can easily do that. My thought is that tenants are going to want to return to the office. You know, there's lots of talk out there about, you know, the new reality that, you know, people will just be working from home. They won't be, won't be coming back to the office. But I think as social beasts, we will come back to the office, and we want to be at the office, and we'll be more productive at the office because it gives us a set regimen for doing work and even sharing ideas and that. So let's make it more, I guess, accessible for them to come back to the office by, again, just monitoring that air and showing them the quality of that space. But when they do come back, and my point about this is that they got a heightened awareness of what is going on. They're going to ask much more detailed questions, and they're going to want to know, how well is my space ventilated and how well is my space filtered? I think we need to tell them that ahead of time and be proactive, not reactive to this. So I'll just end with my contact information. Please feel free to reach out to me if you have a question or even a comment, or if you got some interesting information that's coming across your desk. Be really happy to look at it and discuss it. I love debating this sort of thing, so happy to do that. And if there's any questions now, what I'll do is try to address those if I can find how to actually do that. Oh boy.
Kevin, we've got one question about Cameron McDonald was asking, how long would it take for the UV to clean a room?
Oh, I knew Cam would ask me a question like that. So they're all designed for the size of the room and the amount of radiation from that unit. So if you're talking about the standalone one, you would probably put it in and run the thing overnight, something like that. So it's again, it's the intensity of the light itself and the time that it's in that space. Designed for the space, I should say. So thank you, Cam.
And then there's another question. Is there a simple method to determine what level of MERV filtration your system can handle?
That's a really good question, and it's tough to answer, mainly because you really need to bring in a professional like an engineer, look at your systems, what they're doing now, and get a really good understanding of how they're working. And when I think of a Class A building, usually I'm thinking of the great big built-up systems with the big fan and the big motor and that type of thing, and increasing, from MERV 13 to 14 wouldn't be a real big stretch, but there's a lot of other units in your space, like fan coil units and small rooftop units and makeup air units, that doing that would have an impact on the flow. And when it comes down to, we still need ventilation, and ventilation, as much as I like selling filtration, is probably out trumps the filtration. We want to get air, we want to purge, we want to dilute the air in the space. So there is no easy answer. We looked at this last week with another customer, and we talked about, in some cases, if you don't do that commissioning of your units or recommissioning, then it's almost trial and error. You look at a unit and you try something and monitor the airflow, the amperage draw, or whatever across it, and that will give you some indication of, will the filter still provide the amount of air that you want and clean it at the same time. Did I bypass that one or stick handle around that one?
There have been some questions about the recording, and the recording will be sent out to everybody later this week. So you will get that in your email. And if you have any other questions, you can feel free to throw them in the Q&A.
Yeah, and please feel free to reach out. I appreciate your time. And again, it's I wish I was doing this live, not like this, because it's really weird not seeing anybody to do this. So again, thank you for your time.
Yeah, we have another question here, Kevin, from Jason again, asking, bringing in high percentage of outdoor air is costly in winter and summer. Would it be better to look at improved filtration first?
Yes, thank you for that question. It's a great one. There's mixed talk about that, like bringing in most outside air. It's really hard for us to do that in January and February. But if we filter the ventilation at a really high level, we're diluting that particle again and again. And the more times it goes through the filter, the longer we run the system, even after hours and pre-purging and going through a filter, will do the same sort of thing. MER 13, MER 14, MER 15, or whatever would really remove a lot of that particulate. Bringing in more outside air, you're trying to do basically the same thing, but in January at -30, trying to heat that is really hard, and even harder to humidify it. So they work hand in hand, and filtered ventilation is, to me, you're right up there with lots of outside air. So in our part of our world, filter the heck out of the return air, but make sure that you're getting the performance that it was designed for. So validate those systems. Hopefully that answered that.
Are there any other questions?
Going once, going twice. Vendu.
If not, like I said, we will be sending out the recording with Kevin's information. So if you do have any, there's another. Oh, Jason just commented. Great, thank you for those answers. Yeah, so we will be sending out this presentation, and we will be sending out Kevin's information. So if you do have any other questions or would like to chat about anything, please don't hesitate to reach out. But otherwise, we'll give you some time back in your day. Thanks, everyone.
Thanks, everybody.